Why did the moment the Mars rover picked up a pebble on Mars elicit such excitement and silence from scientists? This smooth, rounded rock, polished by flowing water, holds a secret that could revolutionize our understanding of life's home. Today, it's so dry it can stir up global dust storms, but once it boasted sparkling rivers, thick clouds, and perhaps even teemed with life. The question is how it transformed from a habitable paradise into a deadly desert? And how did our own Earth escape a similar fate? Curiosity's wanderings on Mars are essentially a journey through billions of years of history. On the ancient floodplain at the edge of the Gale Ryan crater, the rover captured layers of rock, a structure formed only by long-term water erosion. It also captured rounded pebbles, their edges smoothed by the flow, much like those found in riverbeds on Earth. This silent evidence suggests that over 3 billion years ago, liquid water indeed flowed on the Martian surface, even forming rivers over 100 meters wide. Mars back then was nothing like it is today. It had a thick atmosphere to trap heat, a cloudy sky to shield it from the sun's intense radiation, and surface temperatures high enough to keep water liquid. But now, its surface is covered in iron oxide, a red desert. What killed Mars? The answer is, surprisingly, the sputtering effect. Imagine the sun. Not only does it shine and generate heat, but it also sneezes constantly, spewing out a stream of high-energy photons and charged particles, the solar wind. These particles can reach speeds of up to 1,000 kilometers per second. When they collide with a planet's atmosphere at such high speeds, like a white ball hitting a colored ball on a billiard table, they can scatter atmospheric molecules and even fling them off the planet. Mars' tragedy is that it has no shield. About 4 billion years ago, Mars's core's cooling magnetic field vanished. Without its protective atmosphere, the roofs of houses vanished, leaving them exposed to the solar wind. For billions of years, the solar wind has been stripping away Mars' atmosphere like sandpaper, flinging molecules from the planet's heat-trapping gaseous energy fortress into space. Even more terrifying, this isn't unique to Mars. On Venus, the Venus Express probe captured the same scene. Solar wind struggling to lift hydrogen and oxygen molecules from the planet's atmosphere out through its side arms. However, Venus's atmosphere is so thick that even after being stripped away, the excess carbon dioxide creates a strong greenhouse effect, ultimately turning it into a pressure cooker with surface temperatures reaching 400 degrees Celsius. This is another form of no-go zone for life. But Earth, also targeted by the solar wind, has managed to survive. Our luck lies deep within the core. The Earth's core is a molten iron-nickel alloy, and its rotation generates a powerful magnetic field. This field acts like a giant invisible shield, deflecting most solar wind particles and directing them around the Earth. It is Earth's first and most critical line of defense. But that's not enough. Earth's atmosphere acts as a soft buffer, absorbing some of the high-energy particles that penetrate its magnetic field. Clouds and ice reflect excess solar energy, preventing the planet from overheating. Even more remarkable is the carbon cycle. Plants absorb carbon dioxide, and rocks fix carbon, keeping the greenhouse effect just right for life. From Martian pebbles to Earth's magnetic field, the contrasting fates of these two planets evoke a larger question. Are prematurely abandoned habitable planets like Mars the norm in the universe? And is Earth an exceptionally rare occurrence? While Earth may not be the only home to life in the universe, it is certainly the most precious. After all, in billions of years of cosmic shooting games, our planet has not only survived but also nurtured intelligent life capable of gazing at the stars and asking why, a miracle in itself worthy of awe.